Hi, welcome to the video on how decision tree works. By the end of this video, you will be able to explain how a decision tree works. Previously, we learned that a decision tree belongs to a non-parametric model. In this video, we will understand how the decision tree works. Let's take an example to understand the working of a decision tree. Let's say you have a data of 20 students out of which 10 play cricket, whereas 10 do not play cricket. So, let's assume that the red plus sign here represents that a student plays cricket and the green negative sign represents students do not play cricket. Now consider that you have the following features of the students: their height, performance in class, which tells us how the students performed in the class tests, and grade, which defines the current grade of the student. Using these features, we want to train a model and predict whether a student will play cricket or not. If you look, this data is available to us. We have a total of 20 students out of which 10 play cricket, and hence the percentage of students who play cricket is 50% in our case. And we have attributes of students like height, performance in the class, and to which grade they belong. Now the teacher wants to identify subgroups so that these subgroups are very similar with respect to playing cricket or not based on given attributes. For example, let's say we are dividing the population into subgroups based on their height. We can choose a height value, let's say 5.5 feet, and split the entire population such that students below 5.5 feet are part of one subgroup and students equal to or above 5.5 feet will be another subgroup. After the split, let's say we got this distribution as shown on the screen. Now you can see that there are 8 students who are below 5.5 feet in height, and out of those 8 students, only 2 play cricket. Hence, in this case, the percentage of students who play cricket is 25% and the percentage of students who do not play cricket is 75%. Whereas there are 12 students above 5.5 feet, and out of those 12 students, 8 play cricket, and the percentage of playing cricket in this case is around 67%. Let's split the population based on performance. Here, the performance is defined as either above average or below average. We will again divide the population based on these categories, and let's say we got a distribution like this. Here, 14 students are above average, and out of these 14 students, 8 play cricket, and hence percentage here will be around 57%. In below average category, we have a total of 6 students out of which 2 play cricket, and the percentage in this case is around 33%. Finally, we have one more variable, grade, and hence we can split the entire data on grade as well. Let's say the students in this data are either from grade 9 or grade 10, and hence we can use them as categories to split the data. After the split, we got the distribution as shown on the screen. A lot of students in grade 9 play cricket, whereas the number is less if we look at class 10. Maybe students in class 10 are busy with their board exams. Let's look at the numbers and percentages. So, in our data, we have 10 students from class 9 and 10 from class 10. In class 9, 8 out of 10 students play cricket, which is exactly 80%. Whereas in class 10, 2 out of 10 students play cricket, which is 20%. This is how we can split data based on the features available to us. If you would have noticed, we have created 3 different decision trees till now. Every time we split the entire data into 2 subsets based on some conditions or decisions, we get a decision tree. So which of these 3 decision trees do you think is better, or we can say that which is giving more confidence to the teachers while predicting the behavior of students, whether they will play cricket or not? But before we answer this, please consider the following. In decision trees, what we want is to have a decision that can separate the classes. In our case, play cricket or do not play cricket completely. So, we want all the positives to be on one side and on one node, and all the negatives to be in the other node. So which of these 3 scenarios do you think is the better split? If you look at the split on grade here, it has 80% of students play cricket which is more than any of the other two splits, which are 67% and 57% respectively. So we can say that the split on grade is better in terms of separating players from non-players. Consider we have one more feature of the students, which tells us whether the students played cricket last year or not. Now let's say we split the entire data based on this feature. There will be two categories, which are yes and no. Generally, students who played cricket last year have higher chances of playing cricket this year as well. And hence, after the split, we got the following distributions. You can see it has separated all the positives from the negatives. If we look at the percentages, there are 10 students who did not play cricket last year, and out of those, none played cricket this year as well, and hence the percentage here is 0. Similarly, out of 10 students who played cricket last year, all played cricket this year, and hence the percentage in this case will be 100%. Remember, this is the ideal case that we have seen here. In practical scenarios, you are very less likely to have such features that can give you completely pure nodes after the split. But what is a pure node? A pure node is in which all the data points exhibit the desired behavior or have the same class. For example, suppose we defined class equal to 1 if someone plays cricket and 0 if someone does not play cricket. Then a pure node would be 1 where for all the data points the class equal to 1. So if we look at the objective of decision trees, it is to have pure nodes or nodes which are as close to pure as possible, so that we can say that the decision tree is really good at segregating data into respective classes. Now let's again consider the splitting of the student population based on class. We saw that split on grade produced the purest nodes out of all other splits, and hence it was chosen as the first split. But does the decision tree stop here? We can have more splits as well. We can split the class 9 node further, let's say based on their heights. Or we can split the class 10 node further based on the performance of students in that particular node. The idea which we want to convey here is that we can have multiple splits, multiple decisions in the decision tree. So the question which you might be having here is how to decide which split is better, or what would be the first split, the second split, and so on. What should be the sequence in which the splits should be made? There are techniques to decide the purity of nodes based on which we can decide the best splitting point and hence make the split. We will discuss how purity of nodes is determined in the subsequent topic. Let's first understand how the predictions are made once a decision tree is formed. Consider we now have a new admission in school and we have the information about this student from his records as shown here. We want to predict whether this new student will play or not. We will use a plus blue sign to denote the new student. How do you think the decision tree will predict the outcome of this student? Let's do this step by step. Consider that the new student is already at the starting node, also known as the root node of the decision tree. In this video, we have used different terms related to decision tree such as root node, splitting, etc. Don't worry about all these terms right now. We will discuss them in detail in the next video. In this case, the student belongs to the grade X. As a result, the new student moves to the right node as shown by the orange arrow in the picture. Now, the new student is a part of the decision node to the right. As we can see in the picture, the next decision to be made is on the basis of performance. As the recorded performance of the new student is above average. As a result, the new student lands on the terminal node to the left as shown in the image on the screen. As this node is not split any further, we now have to make a decision based on this node. As this is a classification problem, we will use the class which is occurring most frequently in this node to determine whether the new student plays cricket or not. Now, as there are two students who play cricket in this node, we can say that the new student is more likely to play cricket, and hence the decision tree predicts the new student as a cricket player. So in this video, we have learned how the prediction works in decision trees. In the next video, we will learn about the key terms related to the decision tree.